So in the last video we have seen what a relation is. That a relation is basically if a relation from set A to B is a set of ordered pairs. So if R is a relation from A to B, then R is a set that has ordered pairs as its elements. Okay, where the first element belongs to A and B belongs to B. So if it's a set of ordered pairs, we have seen in the last video that this makes any relation a subset of cross product. So any relation R is a subset of cross product of A cross B. Okay. From this we can find out the total number of relations possible between two sets. Like if say that the number of elements in A is equal to M and the cardinality of B is equal to N, okay, then what is the number of element in A cross B? The number of element in A cross B is equal to M into N, right? If a relation is a subset of A cross B, it means that number of relations possible from A to B is equal to the number of elements in the power set of A cross B and number of or the number of subsets of A cross B, right? And what is the cardinality of A cross B? It is M into N. So if a set has n elements, then what is the number of subsets? 2 power n. So the number of relations from A to B is equal to number of subsets of A cross B, and this is equal to 2 to the power. This is equal to 2 to the power the number of elements in A cross B. Okay, which is in this case it is equal to 2 to the power m into n. This is the number of relations between that is possible between two sets A and B. Let's say I have two sets, set of numbers only. Let's say set A 1, 3, 5, 7, 9 and B is equal to 2, 4, 6, 8. Okay, how many elements is going to be in A cross B then? Number of elements in A cross B will be equal to number of elements in A into number of elements in B, which is equal to 5 into 4, that is 20. So number of elements in A cross B is equal to 20. So between these two sets A and B, what is the total number of relations that you can make? So A, this is your A, okay, 1, 3, 5, 7, 9, and B is another set which is 2, 4, 6 and 8. So this is the number of elements in A cross B, which is 5 into 4, that is 20. Total number of relations possible from A to B. Total number of relations possible from A to B. You know that this is going to be equal to 2 to the power 20. 2 to the power 20. These many relations are possible. These many relations are possible between these two sets. Let me take some rule R, okay, by which I will relate the elements of A with elements of B, which is less than or equal to. Means that the element of A is going to be R related with B if A is less or equal to B. If this is your relation R, your relation R is basically less than equal to. Okay. So set A and set B are related by a rule less than equal to. Then what are the valid ordered pairs in this case? 1 is less than 2, 4, 6, 8. Okay. 1 will be related to 2 because 1 is less than 2. 1 is less than 4, less than 6, less than 8. Okay. 3 will not be related to 2 because 3 is greater than 2. 3 is not less than equal to 2. 3 will be related with 4. 3 will be related with 6. 3 will be related with 8. Similarly, 5 is not less than equal to 2, so they are not related by R. So 5 is not related by 2 with 2. 5 is not less than equal to 4, so 5 is not R related with 4. 5 is R related with 6. 5 is R related with 8. Okay? 5 is R related with 6. 5 is R related with 8. 7 is not related with 2 because 7 is not less than equal to 2. So 7 is not related with R related with 2. 7 is not R related with 4. 7 is not R related with 6. But 7 is R related with 8. So 7 will be related with 8. But this 9 is not related. The element 9 has is not paired, cannot be paired with any element from set B. So 9 is not related with any element of set B. Okay. So my relation R will be 1 and 2, 1 and 4, 1 and 6, 1 and 8, 3 and 4, 3 and 6, 3 and 8, 5 and 6, 5 and 6, 5 and 8, 5 and 6, 5 and 8, 7 and 8. Okay. This is my relation R. This is my relation R. Okay. Now, if you just interchange the positions in each ordered pair, the second element becomes the first and first element becomes the second. Okay. Then it's a relation from B to A. Okay. What I am saying is this. I am naming any other relation R1. Okay. R1, and this R1 is in place of 1 and 2, the ordered pair is 2 and 1. Okay, I will just interchange the position in each ordered pair in my R1. 4 and 1, 6 and 1, 8 and 1, 4 and 3, 6 and 3, 8 and 3, 6 and 5, 8 and 5, and 8 and 7. Okay. Now this R1 relation is like this is your R relation. The first in R relation is a set of ordered pairs where the first element is from set A, second element is from set B. So we say that R is from A to B. Relation R is from A to B. Here the first element is from set B and the second element is from set A. So R1 is from B to A. Relation R1 is from B to A. Means how the elements of B are related with A. So A to B means that a relation from A to B means that how the elements of A are related with B. Relation from B to A means how the elements of B are related with A. Okay. Also this R1 is the inverse of relation R. Okay. This R1 is also inverse of relation. So let's talk about inverse. Inverse of a relation. This R1 is the inverse of R. That is, I can say that for any relation, if R is a relation from A to B, if R is a relation from A to B, then R inverse is a relation from B to A, such that how R inverse is obtained is you are just interchanging the positions, interchanging the elements in the ordered pairs of R. So this R1, you have achieved this R1, or you have got this R1 by interchanging the positions. Okay. Also, you can understand what is the relationship rule would be then from B to A. R is less than equal to R is less than equal to, then R inverse is greater than or equal to. Okay. From R is greater than equal to, then only the elements are interchanged. So here 1 is related with 2, here 2 is related with 1. Okay. It's just that the elements are interchanged. Okay. So 2 1 4 1 6 1 8 1, and then 4 and 3 are related because 4 is greater than 3. 4 3 6 3. Okay, 6 3 and 6 5 will also be related because 6 is greater than or equal to 5, and then 8 is greater than all of it, right? So 8 will be related with 3, 8 will be related with 5, 8 will be related with 7. Okay, and here the 9 is not related. 9 is not related because none of the elements here are can be greater than or equal to 9. So this is your concept of inverse of a relation. Inverse of a relation means that A belongs to capital A and B belongs to capital B, and if A is related with B, if A is R related with B, then in R inverse, B is R inverse related with A. Okay, the inverse of a relation R, inverse of a relation R inverse is equal to B comma A such that A comma B belongs to R. Okay. So you can also think that what is the inverse of A cross B, because A cross B is also a relation, right? So the inverse of A cross B is B cross A. Inverse of relation A cross B is B cross A. A cross B is a universal set in the context of ordered pairs from A to B. This is A cross B. Any relation R is going to be inside of this universal set A cross B. Okay, any relation is a subset of A cross B. So any relation R is going to be completely enclosed by this rectangle. There is a concept of complement of set. Similarly, what is will be the, if this is relation R, this is the relation R. Okay, this is a relation R. R is a set. So what is the complement of R? The complement of R is R complement is equal to A cross B minus R. A cross B minus R. So A cross B has set of all possible ordered pairs. Any relation has a subset of those ordered pairs. So R complement, the complement of the relation, it includes all of this. So whatever ordered pairs lies outside of this set, whatever ordered pairs that are not in this set, all those will come under R complement. So R complement is equal to R complement is equal to A cross B only. Okay, where A belongs to capital A, B belongs to capital B, such that A belongs to capital A and B belongs to capital B. Okay, and A comma B does not belongs to R. This is your R complement. This is your R complement. Or R complement is equal to A cross B minus R. In one of the video that is titled as set operations involving universal set and null set, you can correlate here this expression from there also, that the complement of the set is equal to uh, universal set minus that set. Okay, this also goes to show that a relation R union R complement will give you what? Will give you A cross B. Okay. Now in the next video, I will start relations of the same set A, which is to say that relations from set A to A. What does it mean that if I say that relation of from A to A, what does it mean? It means that how the elements of a set are related to each other, or how one element of a set is related to some other element in the set. This type of relation is, we call it as relation on set A. Relation on set A. Okay. Thank you very much.